Hi friends, welcome to follow up. In this video, we are going to look at today's daily challenge problem 1609, even odd tree. In this video, we are going to apply the level order traversal of binary tree to here, to the resolution of this problem. So actually, if you are interested in exploring the different ways of traversing a binary tree, you can check out other videos in our channel. So here, let's come back to this problem. So we are given a binary tree. So we want to check if this tree is an even odd tree. So the definition is here, right? So here it says the root of the binary tree is at level index 0, right? So it's, in other words, the level is using 0 indexing. And its children are at level 1 and their children are at level 2. So that the remaining the remaining two items are important. So for every even indexed level, all nodes at that level should have odd integer values and also strictly increasing from left to right. So also we need that the odd indexed level, all nodes at that level have even integer, right? And then it's also strictly decreasing from left to right. So that's the definition. Actually, this problem is marked by marked medium by leetcode. So this is actually rather straightforward due to the definition. We just need to check the definition, right? So here the problem is that, given the root of binary tree, we want to check whether it's an even odd tree in the sense of the current problem. So here we have 3 examples. So notice that level 0 or 2, so these are even indexed levels. So we should have odd numbers, and also those odd numbers should be increasing from left to right. So here it's right? So for the odd indexing level, so we should have even numbers and decreasing. So that's the case, so we return true. And in the second example, so if you look at level 2, so in level 2, so we have 2 3s. This level, the value is not strictly increasing, right? So in example 3, so if you look at the even indexed levels, so they have odd numbers and also they are strictly increasing, right? So if we look at level 1, so this is the odd index levels, so we should have even numbers, integers, but this numbers 9 and 1 are odd numbers, so this is not an even odd tree in the sense of the current problem. So that's the main examples. So the constraints are the following. So the number of nodes in the tree is in the range given by 1, so at least the tree is not null. So this is actually important for to notice, because it's actually in some sense tells us how we should start our coding. So the second number, 10 to the power 5, basically tells us the upper bound for the problem size. And secondly, the node value is the node values are in between 1 and 10 to the power 6. With that said, we are ready to look at the coding part. So let's first see, we need to be able to check whether it's increasing or decreasing, right? So for this, let's not use sort, right, or sorting, because the sorting for a given a length k, say array or level corresponding here, the algorithm, the time complexity will be k, logarithm k up to a constant, right? So this is not good, because we just need to make sure the corresponding levels are either strictly increasing or decreasing, right? We do a linear scan, that will be enough. So for this, we'll write a hyperfunction to address all those. And then the next thing is level order traversal. So this actually, if you are not familiar with this way of traversing the binary tree, you can check out some of the relevant videos in our channel. So with that said, let's do the job. First, I'm going to write a function to do this check, right? Whether it's strictly increasing or decreasing. So because we need to check sometimes for this, we need to check it's strictly decreasing. For the even indexing levels, we need to check it's strictly increasing, right? So let's check a checker, right? So I'm going to pass a array. So this corresponding array, right? Each level corresponding to an integer list. So also I want to make sure if I need to check increasing or decreasing. So here I'm going to introduce a keyword argument, so called increasing or not. So first we set it to be true. And then we can write this one. So we just need to do a check, right? For linear scan for I in range. So I'm going to start from index 1, right? And then length array, right? So this will be ending at n-1, where n is the length of the current array. So if this this array has length 1, it will not enter this for loop, right? So then we are going to check if inc. So in other words, we want to check if it's strictly increasing, right? So if it's inc, so increasing. So if we have some number which is less than or equal to the previous one, then it will not be a valid strictly increasing one. We are going to return false directly, right? So that's the one thing. Another thing is that if not inc, in other words, we want to check if the string, not the string, if the array is strictly decreasing. So in this case, if we have some number, so we want it to be strictly decreasing. But if it's increasing, so it's greater than or equal to array I-1. So in this case, we are going to return false. All the other cases, we're going to return true, right? So this will be sufficient for our purpose here. So next, I'm going to write the level order traversal algorithm. So notice that in order to check the odd and the even for leveling, so we are going to introduce a index, right? So we can do level. The current level is root. So as I mentioned at the beginning, so the assumptions here, like the first one, it says that the tree the tree contains at least one node, meaning it's not empty. We can write like this, right? So that's the reason. That's why I mentioned that this actually has something to do with how we start the coding. So I'm going to also introduce an index. Basically, it's the indexing for the level. So at the very beginning, so the root at level 0, right? And then what we are going to do is val level. What I'm going to do is I get the current array, right? So array will be, let's use list comprehension, right? So for node value, for node in the current level, right? So notice that if idx modulo 2 is 0, in other words, this is the even indexing. For even indexing here, we need all the values to be odd integers, but the corresponding array is strictly increasing, right? So in this case, what we are going to do, first, let's look at the opposite. So if not, say all, say we hope that all the integers is odd, right? So this will give you either 0 or 1. So this is for y in array, right? If not all of this, in other words, at least one integer is even. So this is not good, right? Or there's another one. So if it's not strictly increasing, right? Because here we want to be increasing. So we want to check the current array. So we hope that it's strictly increasing. You can ignore this one because this is the default value for true. But let's write it to emphasize. So here we are checking the array is strictly increasing, right? So then we're going to return false. So this is the condition that it's not strictly, even odd tree. We just return it and break the while, for sure. This is the one case. Another case is, so if the index is odd index, so we hope the numbers are even numbers and the array is strictly decreasing. Let's also focus on the opposite, if not all. So here we hope this y modulo 2 should be 0, right? So if not 0, it means odd. This is not good, right? For y in array. So this is the one condition. So let me add some parentheses so that we don't need to pay special attention to the operation precedence, right? So now let's see. Also, we want to check if the array, in this case, we want to check if it's strictly decreasing. If it's not decreasing, so we are going to return false, right? So this is our major logic. So after the while loop, if nothing has returned, so we should return true. So that's the overall logic. But notice that we need to update this level. So here also we need to update the index. For example, currently we are at this level, so the index is 0. Then we can retrieve the children to get the next level, and then also we need to increment the index. So we can do this by list comprehension again. So it's children for node in level, for child in say node left, node right. So here we write a list. It's the node left and then node right. Left is in the left and the right in the right. This is important, right? Because we want to check strictly increasing property or decreasing property, right? So let's focus on if child. Let's on the non-null ones. So once we update the level, we should update the index in order to make the evenness and oddness of the IDX alternating, right? So this actually forms a full solution format for this problem. So actually this problem can be solved using some, say, other traversals. You can think of different orders, pre, in, and post order. But here we explain the level order traversal. So what actually here, because when we use the level order traversal, we used more space, like here, right, and also each level. But this is this way of doing this code is the way that I feel most natural. So with that said, let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases, right? So with that said, I guess that's about it for the current problem. Thank you for watching.